Okay, so this is a number theory question. And what we're going to do is we're going to write out these factorials to a certain extent. So we're going to say 5 times 4 times 3 times 2. 9 factorial is equal to 12 and n factorial. I'm just going to write it out this way, and you guys will see really shortly what I mean by that. First of all, I'd like to tell you guys something about factorials, which is relatively straightforward. But n factorial over n minus 1 factorial, right? That should be n times n minus 1 times n minus 2 all the way, 1. And that's n minus 1, n minus 2, so on until 1. Cancel these out, you get n, right? So what that means is that n times n minus 1 factorial is equal to n factorial. And that makes sense, right? Because you're just multiplying n to get n factorial. N to n minus 1 factorial to get n factorial. So this is something that I would recommend you guys to keep in mind. And here we're going to use this idea. So 9, if we get n minus 1 is equal to 9, then we get n is equal to 10. So if we have something like 10 times 9 factorial is equal to 10 factorial, that would be cool. And evidently we can get this because 5 times 2 is equal to 10. So 4 times 3 times 5 times 2 times 9 factorial. So we're just rearranging it. It's equal to 12 times n factorial. So now this is just 10 times 9 factorial and then times 12, right? 4 times 3 is equal to 12 times n factorial. So you can cancel these out, right? And that's really easy and nice. That's the other thing you could do is just cancel it out from the very beginning. So you recognize this. So then you get 10 factorial is equal to n factorial. And as a result, n is equal to 10. So that was relatively straightforward. And one thing we got from that is this idea over here. The long route would be to, write out the entire thing and cancel things out and combine things, which eventually we could have gotten. But to notice this property over here that n times n minus 1 factorial is equal to n factorial and canceling out 4 times 3. When you write out factorials, you want to try to write out the smaller ones because, less terms, and then try to cancel those out and keep the bigger factorials, the bigger number factorials, like closed and like try not to expand them because, it's just an extra headache and too many factors. Okay. Next example, let n be the greatest 5-digit number whose digits have a product of 120. What is the sum of the digits of n? So I'll give you some time to work on it, and then we'll come back and discuss.